Mr. Harris here, and welcome to a new video. In this video, we're going to wrap up this periodic table part. So first off, let's talk about the groups in periodic table. So what properties do elements have if they are in the same group? So here, let's recall what exactly are groups. So groups, as you can see, they are the vertical columns going from up to down. And it says over here, elements in the same group, they will have not the same, but similar chemical properties. Now, what does that mean? Now, let's say I pick group 2, for example. Where is group 2? Here, this group. Remember, it's the vertical part. I pick this group as an example. So in group 2, I take out the top 3 elements. There are beryllium, magnesium, and calcium. So here, they could all react readily with dilute hydrochloric acid to produce hydrogen gas. So let's say, for example, here in the test tube, you can see there is calcium, and you see these tiny, tiny gas bubbles being formed? Now, these gas bubbles are hydrogen gas. And in Form 2, I believe, in Form 2, you should have learned one of the tests for hydrogen. How can you test for hydrogen? Remember that it burns with a pop sound with a burning splint? That is the reaction. And also they have little or no reaction with water. So let's say we did an experiment. We're doing an experiment where we add all of these elements into hydrochloric acid. So we add them into hydrochloric acid, and let's see whether there are any reactions. Now, first off, let's look at what elements we have. We have magnesium, calcium, and carbon. Now, magnesium and calcium, just like here in the previous slide, you saw that magnesium and calcium, they're in the same group. So here, they are in both group 2. This is also in group 2. Now, carbon here, if you go back to your periodic table, let's go back there. Carbon is over here. It is in group 4. Okay, so let me go back here and write it down for you. This is in group 4. So just now we learned that when I add magnesium or calcium into hydrochloric acid, it gives off gas bubbles. So yep, let's write that down. It does give off gas bubbles. How about for carbon? Unfortunately, no, it does not. Now what happens in the test for hydrogen? Remember, we put it in a burning splint. What happens? It gives a pop sound. Calcium also would give a pop sound. How about for carbon? Nothing happens basically. And how do we know there is a pop sound given? Is it because hydrogen is produced? Yep, that's why it gives a pop sound for this. And for carbon, basically nothing is produced. That's why there's no sound produced. That means no hydrogen is produced. So which of the elements reacts similarly with dilute hydrochloric acid? Obviously, then it's the group 2 elements, which are magnesium and calcium. Now, do you notice they're not saying it reacts the same? They're using the word similarly. Now, there's a reason behind this. So let's look at some other groups first, and then we'll talk about the reasons. Just like in group 1, we have lithium, sodium, potassium. Of course, there are a couple more down there in group 1, but they all will have similar chemical properties. Like, for example, they would react with air readily, and they can react with water. Especially group 1 elements, they are very, very, very reactive with water. Here is group 7. This is group 7. They are, if you notice, the color now is pink. When the color is pink, that means these are non-metals. Now, the interesting thing about group 7 is these non-metals, they can react with both metals and non-metals. Say, look up here, you have chlorine and sodium. This chlorine is a non-metal up here, and sodium, as we know, is a metal. And by the way, when these two react, they form sodium chloride, which is your table salt. And down here, you have chlorine, which is a nonmetal, and phosphorus, which is also a nonmetal. So this is pretty interesting. It can react with both metal and nonmetal. And you also have group 8. There should be another one here. This should be group 8, or you can call it group 0. Okay, please, maybe in your book it might be wrong as well. Please add back one more Roman numeral there. 1. Now, group 8, they're called the noble gases because they are very unreactive. They do not really react with anyone else. So elements in the same group, they have similar chemical properties. It's just similar, okay? But the good thing is if we know, for example, I have something in group 2 that reacts with hydrochloric acid to form hydrogen, that means all of them in group 2, they will react with hydrochloric acid in the same way, in a similar way. That's what it means. So anything that works in group 7, it will work for all of them in a similar way. Remember, the keyword is similar. Now, why, of course, why aren't they similar? Because they may have different reactivity. Some may be more reactive, some may be less reactive. Let me take the same group 2 as an example. So I'll give you the hint. Basically, the lower it is, the lower the element in the group, the more reactive it is. I'll write it for you. The lower the element in the group, the more reactive it is. Now, one disclaimer here, this is primarily for metals only, so group 1 and 2. This is mainly for groups 1 and 2. Now, for group 7, it's the opposite. But for now, let's just focus on group 2. The lower the element in the group, the more reactive it is. So let's say I have beryllium here. Magnesium is more reactive than beryllium. Makes sense? Because it's lower in the group. But when I go even lower, even further, calcium is even more reactive than magnesium. Okay? So let's just think about this same experiment again. When I add calcium into dilute hydrochloric acid, these gas bubbles are formed, right? Now, the reaction would be vigorous, or will it be more vigorous for magnesium or for calcium? Of course, because calcium is more reactive. So for this, the reaction will be even more vigorous. For this magnesium, maybe not as much. So that's the story behind it. Okay? So here, this is what I was talking about. When we get magnesium or when we get calcium, we put it into hydrochloric acid. Which one will react? So we can compare them and see which one would react much more vigorously. So we can repeat it with some other acids. This time we're using very dilute nitric acid. Basically, you can try any different thing, and you'll notice that like this question is asking which element is more reactive, is it magnesium or calcium? And the hint they're giving you is the metal that gives off more gas bubbles, that means more hydrogen, that would be more reactive. Then obviously, of course, it would be calcium because it is lower in the group, and thus it is more reactive. Now I'll repeat again, this lower in the group thing is only for metals, only for group 1, group 2. So again, elements in the same group, let's refine our statement that we learned earlier. Elements in the same group, they have similar chemical properties, but they may have different reactivity. Some may be more reactive, some may be less. That's the key point here. And let's see some of the daily uses of elements, some applications. Like in group 1, lithium, it's used in batteries. Sodium used in lamps. In group 2, magnesium, we use it in fireworks. Group 3, aluminium, we can use it in window frames, even in aircraft, aluminum cans, foil, carbon, used in your pencil. Also, actually, carbon. There are different forms of carbon. Diamond is a form of carbon, graphite is a form of carbon, and we'll learn some more if you take chemistry. We have silicon used in semiconductors, in your computer. Nitrogen, we can store living cells in nitrogen. Phosphorus used in matches. Oxygen, not only is it useful for your photosynthesis reactions or respiration reactions, but also for welding metals. Sulfur, making rubber. Chlorine for water purification. Iodine as an antiseptic. Helium for, I'm sure you've heard of helium balloons. And neon for a lot of these advertising signs that we see. So now let's wrap up this whole topic 13.2 with checkpoint questions. Okay, in the previous video we learned that the periodic table, they are arranged in order of, in order of increasing atomic number. Remember, they're increasing the number of protons. Or we could also say increasing the number of electrons, unless it's an ion. But usually in the periodic table, there are no ions. Option 2, which of the following statements about magnesium and calcium are correct? Magnesium, we just learned it's in group 2. Calcium is also in group 2, but calcium is lower. Okay, let's look at our options. Both are group 2 elements. Yep, that is definitely true. Both react with hydrochloric acid to produce hydrogen. Yep, we just did that experiment. We just saw it. This is true. And the last option, it says magnesium is more reactive than calcium. No, it's the other way around. It should be it's maybe I'll just say magnesium is less reactive than calcium. So 1 and 2 over here, I can't show you the options, but the answer should be B as well. 1 and 2. Right? So that's a wrap for this video. I'll see you in the next one. Bye.